Hello calculus students, and specifically general seekers of truth. Welcome to the video on determining interval of convergence for a Maclaurin series. And we're given a Maclaurin series here, and we want to find the values of x. Okay, so this is x here is a variable, f of x is a function. So this is a function that's expressed as a series, an infinitely long series, and we want to know for which values of x will the series actually converge. Because if it does converge for certain values of x, then it's very useful in that interval, and if it doesn't converge, then we have to use some other methods here. So I am going to use the ratio test. Okay. And the ratio test, it says that if the limit as n approaches infinity of the n plus 1 term over the nth term in absolute value is less than 1, then the series converges. Okay. So if you compared any two consecutive terms and this ratio here is less than 1, in other words, the numbers or the ratio between the next term and the previous term are getting smaller and smaller, eventually this series is essentially a cousin of the geometric series, and it will converge. So we're going to apply this to here. So in this case, a sub n plus 1 over a sub n, the absolute value, is equal to, and all we're going to do is take n plus 1 and substitute it in here into the general or the explicit form. So I have 2x, n plus 1 plus 1, so it's going to give me n plus 2 in the numerator there. In the denominator, we will get n plus 1 plus 1, so this will give me n plus 2, times. Now, instead of dividing by a sub n, it's the same thing as multiplying by the reciprocal, so we take the general term again, n plus 1 over 2x quantity to the n plus 1. Absolute value around the whole thing, that's very important. And then let's see what happens here. I'm changing colors here just so we don't get stuff mixed up. And some of this stuff might get pretty gnarly and complicated, so we just try to cancel things out slowly. 2x to the n plus 2, and this is the 1 right here. 2x to the n plus 1, they're almost the same thing. They're going to cancel out, and all you're going to have left is 2x. Then the two remaining terms, n plus 1 and n plus 2, they don't really cancel each other out. And now we want to take the limit as n approaches infinity of 2x n plus 1 over n plus 2. Now this limit here is with respect to n, so the 2x is treated sort of like a constant. So this, in the long run, if you just look at leading terms, this will approach 1 times 2x. So this is equal to the absolute value of 2x. Okay? Now we know that this limit, if it is less than 1, then the series will converge. So we do a test by saying, well, the absolute value of 2x must be less than 1 for the series to converge. And we can do some basic arithmetic or algebra here, pull the 2 out, because absolute value of 2x is the same thing as positive 2 times the absolute value of x, and that means the absolute value of x must be less than 1/2. Okay? So our potential interval of convergence is x is between positive 1/2 and negative 1/2, okay? Because that's what absolute value of x really means. Now we're not done, because we need to check for the intervals, the endpoints here. We need to plug negative 1/2 and positive 1/2 into the original series in order to see if they will converge at those endpoints. In other words, do we need to add an equal sign down here, because that's also significant. So first, if x equals 1/2, and all that means is I'm going to take 1/2 and plug it into here and expand the terms and see what happens. But this problem is nice enough that it sort of expanded some of the terms already, so I'm going to take 1/2 and plug it into each one of these x's. Okay. So the first term here, the series that we have is 1/2 times 2, so that's just 1, plus 1/2 squared times 4, so 1/4 times 4, so that's just 1 over 2. And then 1/2 cubed is 1/8 times 8 is 1 over 3, plus 1/2 to the 4th, which is 1/16 times 16 is 1 over 4, so on. Okay. So this is none other than a harmonic series. So it will diverge. Okay. So that's if x was equal to 1/2. Now consider what happens if we get we check the other endpoint. Let x equals negative 1/2. Then the series that we have is, so if I take negative 1/2 and I plug it into here, my first term is going to be negative 1. My second term is going to be negative 1/2 squared, which is 1/4 times 4 is 1 over 2. So I'm going to list out some of the terms here. So I'm going to have negative 1 followed by positive 1/2. Then if I take negative 1/2 and plug it into this part right here, I get negative 1/8 times 8, so that's negative 1 over 3. And you can see pretty quickly here, this is negative 1/3, and then you're going to get positive 1/4, dot, dot, dot. Okay. So this means that this is a alternating harmonic series. Okay, an alternating harmonic series, which we know will converge. Okay. So what that means is that x values will not only converge in between negative 1/2 and positive 1/2, it will also converge at negative 1/2. So that this little like less than or equal to sign is necessary. Okay. Alright, so there we have it, an example of how to find the interval of convergence. Now if someone were to ask you for the radius of convergence, in this case it would be 1/2. The center here is at 0, so x is, the middle point between negative 1/2 and positive 1/2 is 0. So it's centered at 0 with a radius of 1/2. As always, if you have questions, please ask. Thank you for watching and have a wonderful day.